All right, let's do some perpendicular bisectors. Let's have everybody turn to page 41 in their packets. Start in a somewhat strange place, but we're going to go back and do the other ones on Monday. We're going to do 5, 6, and 7 today. So it's 5 and 6 on page 41 and number 7 on the next page. And again, remember the instructions for this are write the perpendicular bisector of the line that goes through the points 4, 2, and 8, 10. I should say segment that goes through 4, 2, and 8, 10. And again, what this really looks like is if I had, you don't have to draw this, but if I had a little graph and we were going to plot the point 4, 2, which says here, and 8, 10, which is up here, if I had a segment that connected those 2 points, what would the equation of the line perpendicular to that and going through the middle, the bisector? So it bisects right about here, perpendicular would be right about there. I'm just sketching this, but we'd be looking for the equation of this line, the perpendicular bisector of these 2 points. So we'd be looking for that line there. Okay, so that's what we're going to do today, but we're going to start on number 5 on the next page. So 5 on 41. Okay, so perpendicular bisector, I'm going to set it up like in 4 steps. That's not a graph, by the way. That's just 4 little steps. I'm going to go top left, and I'm going to say, let's find the slope. The slope between this point and this point. So slope is y2 minus y1 over x2 minus x1. When I plug in, I have my x1, my y1, my x2, my y2, and my y2 is negative 2, my y1 is negative 3, my x2 is 3, and my x1 is negative 5. Got a lot of negatives going on here. Let's see. I have a leave, add, opposite. So negative 2, and then I go up 3. That puts me at 1. Leave, add, opposite again. I have 3 plus 5, which is 8. Okay. But I don't want to use that slope. I want to use the perpendicular slope. The perpendicular slope wouldn't be 1 over 8. It would be negative 8 over 1. So that's the slope that I really want. Remember, perpendicular, use a negative reciprocal. Okay, step 2, we need to find the midpoint. Because bisector, in perpendicular bisector, really it means midpoint. A bisector goes through the midpoint. So the midpoint formula is add up the 2 x's and divide by 2, and add up the 2 y's and divide by 2. So if I add up my 2 x's, I get negative 5 plus 3 divided by 2. If I add up my 2 y's, I have negative 3 plus negative 2 over 2. And that turns out to be, let's see, negative 5 plus 3 is negative 2. Divided by 2 is negative 1. And negative 3 plus negative 2 is negative 5. So that would be negative 5 halves, because that's not going to reduce any further. Okay? Negative 2.5. All right, step 3 is going to be y equals mx plus b. Y equals mx plus b. Now I have my x, my y, and my m. Alright, those are the three things I have. Again, the m, the x, and the y. Right? So let's see, the y is going to be -5/2. The m, -8. And the x, -1. So then I have, let's see, -8 times -1 is 8. Now I have to do -5/2, which I'm going to make this into -2.5. Easier that way. If I subtract 8 from both sides, I get -10.5 for b. My last step is to just write the equation of the line. Our final equation is y equals. Now remember, you just need an appropriate slope and the correct b. Connecting these two things, you have everything you need. So y equals -8x minus 10.5. Or that's the equation of that line, the perpendicular bisector that goes through those 2 points. Really quickly, if I went to Desmos just to graph this, I plotted the point -5, -3, and the point 3, -2. So what I want to do is pretend these are connected, but I want the perpendicular bisector of that, so it would look like this. So our answer was y equals -8x minus 10.5. And if you look at that, it does appear to be exactly in the middle of these two and be perpendicular to whatever that connector would be. Okay? So we're good. All right, now look at the next one, number 6. I'm going to break my paper into 4 steps again. And the first one, just like the last problem, is going to be find the slope. Slope is y2, it's a messy one, y2 minus y1 over x2 minus x1. So this is x1 and that's y1. That's x2 and that's y2. It looks like I have y2 minus y1. And on the bottom I have x2, which is 4. And I have x1, which is 6 minus 4 is 2. Here I have leave, add, opposite. -4 go up 2 more. 2 divided by -2 is -1. But I don't want that slope. I want the slope perpendicular to that, the perpendicular slope. If I take 1 over 1 and turn it upside down, guess what? I have 1 over 1. That doesn't look a whole lot different, but you do have to also change the sign, so now it's positive. So we could just say the slope is 1. Step 2 is to find the midpoint. And midpoint is add up the 2 x's and divide by 2, add up the 2 y's and divide by 2. Add up the 2 x's and divide by 2. And then I'm going to add up the 2 y's and divide by 2. That will give me -6 over 2, which is -3, and 10 over 2. So now I have my midpoint. Step 3 is going to be y equals mx plus b. We're going to solve for b. So blank equals blank blank plus b. What do we already know? M, X, Y. So what goes here? And then what goes in the M slot right here? And then what goes in the X slot right there? Alright, so then you multiply these two together, you get -3, one time thing. To solve for B, I'll add 3 to both sides. It turns out that B is 8. So I'm ready to write my final answer now, because I have the correct slope and the correct y-intercept. So the answer is 1x plus 8. Let's check Desmos to see if this looks reasonable. So the original 2 points were -2, 4 and -4, 6. And I am going to then type in what we got for a final answer, which was 1x plus 8. And if you look closely there, it appears to go through the middle of these two right here, the midpoint, which is right here. And it also, if there had been a line drawn between these two, a segment, it would go through that perpendicularly. So you can tell you're right by looking at that. So let's wrap it up right there for Friday. We did some perpendicular bisectors. We checked on Desmos. I want you to upload page 41 to Google Classroom. That combined with the Ed puzzle will give you credit. You have an awesome weekend.